easily. They given one of the equilateral triangle. So in the equilateral triangle, we taken three charges: q, q, minus 2, plus q, plus q, minus 2. Three are arranged in the three corners of the equilateral triangle. In this case, what they are saying, so what is the magnitude of electric dipole moment of the system? What is the magnitude of electric dipole moment of the system? So here, this minus 2q which is there, I can write as minus q as minus combination. So here minus q plus q forms one dipole, and another minus q plus q also forms another dipole. So there are two dipole system is going to form here. So what is the direction of the dipole? Always from negative to positive. So this is the direction of the dipole moment in the case of this. So this is the direction of the dipole moment in the case of first one. Similarly, what is the direction of the dipole moment in the case of second one? In the case of second one, this is the direction of the dipole moment in the case of second, negative to positive. So this. Now these two dipole moments are separated by certain angle. What is the angle? This is equilateral triangle means automatically you have to understand this is the angle 60 degrees. Now what is the magnitude of electric dipole moment of the system? System means two electric dipole moments. One is called as P, second one also P, because both magnitudes are same, directions are different, subordinate angle. So in this case, the resultant of these two will come in the along the diagonal as well. Like this is the direction of the resultant dipole moment, that is net dipole moment direction. So this net dipole moment direction we can find it using parallelogram law of vector addition. Here two dipole moments are there, one is P, second also P. So according to parallelogram, that is P square plus Q square plus 2pq cos theta is the formula for that. If you apply here, what is P? In the place of P, we have dipole moment P square. In the place of Q also we have a dipole moment P, that is also P square, plus 2 into one of the dipole P, second one also P, into cos of the angle. What is the angle between these two? 60 degrees from the triangle. So if you solve this one, cos 60 is equal to how much? Cos 60 is equal to 1 by 2. So if we cancel that one, so P square plus P square plus P square, P square plus P square plus P square, that is totally you are going to get, so root 3P you are going to get. So net dipole moment at that point is equal to root 3 times of P means dipole moment. Dipole moment we can write in terms of charge into length of that. What is the length of that one? Here length of the triangle, that is QL. So root 3 QL is the answer to your question. So option C is correct according to given options. Look at the next problem. What is given? An electric dipole consisting of two charges plus q minus q. So already you know the plus q minus q, two charges separated by distance of 2a. Now its center is on x-axis. At x equal to x1, the point along x-axis is positive x direction. Means what is the meaning of that one? They taken one positive charge, one negative charge separated by distance of how much? 2a. Now these are lies along the direction of the x-axis. This is the way they are aligned. Along the x-axis they align. Now in this case, what they are telling here, along x-axis, now the dipole moment in the non-uniform field, which is, that means in this direction, if you apply the electric field, what direction? Same direction is electric field is acting. So in the same direction electric field acting, that electric field value is equal to C x times of I cap is given. So here you have to understand here, dipole moment is always from negative to positive. So if you taken this one as a -1, so in this case what I am doing is I am taking this as negative charge, this one I am taking as positive charge. So dipole moment will be in this direction. So they are asking what? The dipole in the non-uniform given by. So what is, which option is correct? They are asking. What is the options are given? Forces are asking. Net force on the dipole is given, net force like that they given in terms of vector form, right? So here first force related to electric field. So already we discussed in the previous concept, whenever you taken any dipole in the electric field, in the uniform electric field, what happens? Net force will be 0, but torque will not be 0. But in the case of non-uniform electric field, if you see this one, this is a word most important, non-uniform electric field. By looking at that word, you have to understand the formula, otherwise you can't solve it. So non-uniform electric field net force will not be 0, not equal to 0. So in this case, they're asking the options given in the form of net force. So what is the net force formula? Net force formula is equal to nothing but dipole moment into dE by dx is the formula for rate of change of electric field. In the case of dipole, where variable electric field is taking place, non-uniform electric field takes place. So in this case, what is dE by dx not given? So electric field is given. So differentiate that electric field. So dE by dx equal to, I can write as, that is d by dx of, that is Ce into, sorry, Cx I can write, that is Cx we can write, that is I is the direction of that one, in the direction of the x-axis. So C is constant if we taken, that is C into dx by dx is 1 anyway, so the value of that one is you are going to get C. So force is equal to what I can write, the force acting on that one is equal to nothing but simply I can write P into C I can write. So what direction it is anyway, dipole moment and electric field both are in the same direction, means force is also will be in the same direction, force also will be in the same direction. That is one of the thing we need to understand. If the dipole charges are in the same way, look at the dipole charge, first one is plus, second one is minus. So in this case, center x equal to 1, its point charge x-axis given. So plus and minus is given. We taken minus and plus. So I think it is the answer, we are going to get minus. So in terms of I cap. So what option we have a correct here? Net force on the dipole is equal to minus Cpi. Second option may be correct. Okay. If the minus and plus is given, means plus Cpi you are going to get. Now we are going to discuss the next problem. The problem is given a small dipole of its dipole moment P directed along z-axis. Look at the diagram they given. This is the z-axis. In this direction, there is a dipole moment is present, located at origin. Where is it is? At the origin of the coordinate system. We will redraw the diagram once again. Consider the point S, which is located at the position. This is the point S we taken, which is at a position of R and making an angle theta with respect to dipole moment direction. So that means at any angular position, constant basis. Now, if the net electric field at point S, that means at this point, the net electric field at this point, perpendicular to P. Perpendicular to P means, that means this is the way we are getting the electric field. That electric field, okay, at this point S must be perpendicular to, means this is the P. If you say this is the direction of the dipole moment, and this is the direction of the electric field. So that means this is the point at this is the direction of the electric field they are asking. Then its magnitude is, what is the magnitude of this electric field at this point? This is the question they are asking. To understand this one, we have to understand the clear, okay, diagram of this one. First, the direction of the dipole moment is in this direction. Next, the point which you chosen from the axis, this is the point we chosen. I can say this is the point, I can say that point is called as S point, which is making an angle theta. Now dipole moment P is acting as a looking here. Now you can resolve this P. This is a vector quantity. You can resolve into P into components. Before that, so what component you will get? If you resolve this into components, one component you will get as P cos theta. This is one component that I can write as P cos theta component. And second component you are going to get is perpendicular to that one. So the component of that one you are going to get is in this direction. That is nothing but P sin theta. Here our concept of this, already we have an idea about this component. Due to this component, the electric field at this point will be in the same direction, that you take it as E1. Next, due to this P sin theta component, the electric field at this point will be in this direction. That is also, you know, that is E2. So E1, E2 are the electric fields at that point. Now these electric fields at that point making angle, how much angle they are making? If you take an axis here, so at this point, now this E1 making an angle theta with respect to, that is, z axis, as we are taking here. If we taken as z axis with respect to z, now according to geometry, this is theta, means this angle E2, how much angle it makes? According to that one, if we taken geometrically, if we calculate this one, this angle will becomes is equal to 90 minus theta. It becomes, this angle becomes 90 minus theta. You can check it that one if you want. This is theta, means this also becomes theta. Okay, this also becomes theta, and remaining angle becomes 90 minus theta by using the adjacent angle concept. So here E1, so they are asking the concept perpendicular to P. So this is the dipole moment, this, which is the perpendicular. I'm taking in red color. This is perpendicular. This is a perpendicular, right, direction. So perpendicular direction to the P. So how much angle it is making? It is making an angle 90 degrees. So we need to find the electric field intensity to the perpendicular direction of the dipole moment. So this direction we want. Now if you observe this one, to find it this one, first what is required here? The electric field intensity in this direction that I am writing as E perpendicular direction is equal to this direction I am writing as E perpendicular. E perpendicular direction is equal to get it that one first, this E1 resolve into components. If you resolve into components, first component you are going to get E1 cos theta, one component, and second component is you are going to get, this is in the direction of the above, so that is E1 sin theta. Similarly E2, if you resolve into components, you get, this is E2 sin 90 minus theta, so that is cos 90 minus theta, you will get E2 sin theta, you will get. And in this direction we have another one, that is E2 sin component, sin 90 minus theta becomes cos. These are the two components. So perpendicular direction we have two electric fields are there, that is, one is called E1 sin theta component, plus second one is called E2 sin theta component, E2 cos theta component. E2 cos theta component. Now we need to find the value of this sin theta and cos theta first. First we are going to derive the equation, then after we will go for according to options. Now if you observe this one, so in the case of perpendicular, what is E1? E1 is equal to nothing but, you know that, that is the concept of due to P cos theta. What is the, okay, electric field intensity? That is nothing but 2P cos theta, because the point is along axial line, E1 is the axial field. So 2P cos theta by, that is K into, K is called 1 by 4 pi naught, 2P cos theta by R cube is the formula for that, because R is the distance of that point, and you know the derivation of that electric field intensity due to the dipole, which is making an angle theta at any angular position in terms of component is, that is E1 is equal to K into 2P cos theta by R cube is the one of the formula. Next, what is E2? E2 is nothing but, which is E2 is another component. What is that another component? This component is exactly opposite to P sin theta. That's why I can write as, that is just K into P sin theta by R cube is the formula. Now apply this E1, E2 in the above formulas. What you are going to get? E perpendicular is equal to nothing but E1 is equal to, I can write as, what is E1? That is 2kp cos theta into sin theta, because we have already here sin theta, by R cube, plus E2 value, that is kp sin theta, we have here cos theta by R cube. Now that means I can write this one, E perpendicular is equal to, so 2kp cos theta sin theta cos theta, there are totally I can write as 3kp cos theta sin theta by R cube. This is the equation of electric field which is perpendicular to the z-axis. So in this case, if you see the options, we are not having any options in terms of like that, okay, cos theta, because thetas are cos theta, sin theta is not there. That means we need to find the theta value here. How to find the theta value? If the net electric field at that S perpendicular to P, then its magnitude is. That means you need to understand that, suppose if you take the consideration, okay, So what consideration along x-axis? If you see this one, along x-axis, E1 cos theta, E2 sin theta, both are opposite. Along x-axis, both are opposite. Take the concept of that because it may be useful to find the certain values. Both are opposite. Both are opposite means net field will be, you can take it as 0 like. If you take it and we can go to, okay, solution of that. So in the question only we have a concept here. If the net field at point S is perpendicular to me, net field means total field. If the total field at point okay S is perpendicular means what is the field along x-axis? 0. So that means they given concept very clearly. So electric field along x-axis 0 means that is E2 E1 cos theta must be equal to E2 sin theta. So in this case, what is E1 cos theta? You can find the relation E1 is equal to already written, that is k into 2p cos theta into cos theta, that is cos square theta by r cube will get. This is k into p sin theta, that is nothing but sin square theta by r cube, because E2 value is equal to sin theta base, right? In this case, I can cancel kp both the sides, r cube I can cancel. Cos square theta, 2 cos square theta is equal to sin square theta we got. Now this becomes 2 cos square theta is equal to sin square theta, we can write in terms of 1 minus cos square theta. Sin square theta plus cos square theta equal to 1, and sin square theta is equal to 1 minus cos square theta. That if you make it here, this becomes 3 cos square theta is equal to 1, and cos theta is equal to, you get 1 by root 3. Cos theta is equal to 1 by root 3. So cos theta is equal to 1 by root 3 means what is the value of sin theta? Okay, what is the value of sin theta? You take the triangle. In the triangle structure, cos theta means adjacent hypotenuse, that is 1 by root 3 is the cos theta. Now if you use the Pythagoras theorem, what you are going to get? The value of y square is equal to root 3 square, that is nothing but root 2 you are going to get. If you calculate this one, how much you are going to get? That is nothing but y square is equal to, so this is y. If you say the y value, I can write as y square equal to root 3 square, 3 plus 1, 4. Y is equal to, you are going to get 2 n. If you got 2, it has to be 5. So it is not the 2 value, just take it. So what this y value you are going to get? This y value after calculation, you will get root 2 value. This is equal to, you are going to get root 2. So if you taken the root 2 value, that means sin theta is equal to how much it becomes? Root 2 by root 3 you get. So substitute here, electric field perpendicular to that direction is equal to 3 kp into what is cos theta value? 1 by root 3 into what is sin theta value? Under root of 2 by 3 root 2 by root 3 by r cube by. So if you solve this one, so root 3 into root 3 nothing but we are going to get as okay, that is 3, that 3 get cancelled, so we are going to get here, okay, we have a root 2 kp by r cube here. Check the solution once. If you see the options, what are the options we have? So what is k? K is nothing but constant 1 by 4 pi epsilon naught, I can write, and root 2p, this is root 2p by 4 pi epsilon naught r. So option C is correct, root 2p by 4 pi epsilon naught r. So little bit care has to be taken, so to while solving the problem of this. This is one of the advanced level of problem. Now last question of this dipole concept, and in this question what is given here? They given a dipole, an electric dipole moment P is located at a distance of r of wire with uniform linear charge density is lambda. That means already we discussed in the previous class, and there is electric field due to linearly charged wire. So that linear charge density lambda wire producing the electric field, and they are asking force on the dipole when P is parallel to y. Means we taken one of the wire, this is a wire which is positively charged length of infinite length, where the charges are distributed over the length of linear charge density lambda. Now at a point of distance, perpendicular distance r, we placed one of the dipole. The dipole when P is parallel to the wire, means condition of this one, the dipole moment is parallel. That means this is the direction of the dipole moment. You can take. So the wire and the dipole moment both are in the same direction. Now what is the electric field? What is the force on this dipole? They're asking. So is this there is any force or not? We have to understand. First, you have to understand that how this electric field is applies the okay electric field at this point on this dipole. You know that due to infinite wire, at a point the electric field only we have horizontal electric field. The what is the electric field formula? That is equal to lambda by 2 pi epsilon naught r is the formula. Net electric field. But what is the electric field along y direction? That is equal to 0. There is no electric field along y direction according to the concept of linear charge, okay, distribution of the wire. Due to that, electric field intensity at any point at a distance of r is equal to nothing but we can write as lambda by 2 pi epsilon naught. Now, what is the force concept? Force acting on any dipole is equal to due to electric field. Concept is dipole moment into rate of change of electric field if any electric field is changed. But if here electric field is anyway at that point is fixed value, x is the position of the point is along x-axis changing, okay, fixed point, but y-axis the dipole moment is changing. But our concept of force at that point on the dipole is equal to p into that. If you want to differentiate this one d by, that is in terms of dr, you have to write d by dr is equal to lambda by 2 pi epsilon naught r, you have to take. But in this case, is the r value is changing? Means no, r is not changing. That's why I can write simply force acting on this one, this constant variation is, it is complete constant 0. So the force acting on the dipole is equal to 0 at that position, we can say. Suppose if the dipole is present in the direction of the axis, that means I'm taking the red color. If the dipole is placed as you're looking like this, the dipole is placed like this, that is P1. In this case, I can write the force acting on that one is equal to force equal to P into that is d by dr of lambda by 2 pi epsilon naught r, I can write that is P1 of. So now the r value changing from here to here. So there is a change in r value, that is dr we can say. So r can be differentiable. In this case, if we differentiate this value, we are going to get P1 into lambda into, if we differentiate 1 by r, okay, 1 by d by dr of 1 by r is equal to how much you get? 1 by r square you get. That means minus we have, that is P1 lambda by, that is 2 pi epsilon naught r square here. So these are the concepts you have to know that according to the condition of that. So in this case, it is given parallel, that's why the force is 0. If it is perpendicular, then the force is not 0. This is the formula for that. So in this, according to this question, what is the correct answer? The C is the correct option for this question. So this is the end of your dipole concept, and we can go for next one, Gauss theorem, and that Gauss theorem, after completion of theory, we will go for problems in that Gauss theorem.